Let's do GOFAST, because I think GOFAST is the one that's very accessible to people. GOFAST is this one that looks
2015 UFO encounter taken aboard a Navy fighter jet from the nuclear aircraft carrier USS Teddy Roosevelt off the eastern seaboard near the Florida coast. And going so fast that they have never seen anything that has that kind of technology.
It looks like it's going fast, and that's the thing. It's kind of an illusion. It looks like it's going fast because of the parallax effect.
Wrong.
So I think what we're looking at is the tail end of a jet plane, and that would appear as a big glare that would kind of obscure in the same way that this flashlight here, when I point it at the camera and turn it on, you get a big glare that obscures it.
What?
The wind at 22,000 feet can be moving very, very fast, whereas the wind at 11 could be moving slow and or in a different direction. So what it looks like to me is something that's moving at wind speed, and the most likely thing is a balloon. And from that, an even more likely thing is that it's a loose weather balloon. It could possibly be a very large bird. People, make fun of me for suggesting this, but there is a possibility that it could be something like a pelican, like a large enough bird, if it's well insulated.
So whatever this object is, it's got a wingspan of about a meter. So if I remember rightly, just a first guess, Canadian geese have a wingspan of about a meter. And they do. I wonder what altitude they typically fly at.
A fucking goose? What? Does he think we're idiots? Like, how would fighter pilots ever fight anybody? You know how many geese are flying around the air? Like, how would I find any targets? Like, what happened? Notice you bombed that target? Be like, no, man, sorry. Team got killed on the ground. Just locked a goose. No, man. So I'm usually a pretty laid back guy. I don't get that fired up normally, but I just keep seeing video after video and article after article on mainstream media, CNN, USA Today, BBC, CNN, about this guy who obviously has no clue what he's looking at. You don't know what you're talking about. It is so blatant to me. He didn't talk to a single pilot or weapon system officer or anyone really who's ever used one of these pods as their job or used them on a consistent basis. Okay, it's just so obvious that he's wrong, and yet he's going on national TV and he's saying, just spreading all this misinformation. So I'm going to prove easily. It's so easy to prove that Mick West's totally wrong. First I'll do the GOFAST video and show you definitively with physics and models and just protractors and measuring rulers that Mick West's totally wrong. It is not a freaking goose or like a plastic bag or a weather balloon floating around, and we know what we're talking about. Okay, so should be a good video. Stick around. Easiest way to debunk the debunked video is it's just focal length, guys. So the camera, the targeting pod, if anyone's used, is obvious to anyone who's ever flown these things, is you can't focus at something 10 miles away and then focus at something 5 miles away. It just is not how physics works, right? Especially in a dynamic scenario. Like, think the airplane is moving, right? 5 miles a minute, okay? Relatively slow for a fighter, right? So 5 miles a minute is going across. The target is also moving, okay? So this is a dynamic situation. It's not just, this pointed there and this pointed there, so it's closer. Okay. So first thing is we get a lot of information from the background, but the focal length, okay, it has to focus at a certain range. It's still using normal optics. Okay, infrared picture is still using normal optics. Okay, so this is one video I could find. So Rafael Lightning Advanced Targeting Pod. It's not the best. Okay, this isn't an F18, but the capability of the pod is the same. Okay, so I'll talk to this. So this is at 24 nautical miles. You can see here at 24 nautical miles, I can make this out as an airliner. A clear edge there, and then this is the TV mode. So zoomed in, TV mode's a little more zoomed in, okay? There's two lenses and two sensors, essentially a TV sensor and IR sensor. And then this is the TV mode. So you can see here, we can put it in picture-in-picture mode in the Viper. So we can have the IR and then also the picture-in-picture mode, which I'll even leave up at night actually, because then I can see it flashing. And I've used this to read the tail number of tankers when I've gone to refuel. Sometimes you show up at a refuel and there's multiple tankers in the stack. And so you don't know which one really is yours, and there's radio comm. So what I've done is I've actually looked at the tail number using the TV mode. And also you can tell from distance if it's with the IR mode, if it is a KC-135 or a KC-10. So can ID these things at 24 nautical miles? I could probably tell with the difference between a KC-10 and a KC-135. Okay, I could tell by this, there'd be another engine here, probably pretty easily, okay? Now I want you to look at the background, okay? So this thing's 24 miles away. Look how far it's moving in relation to its background, and look how the background moves, okay? Okay, oh, it's short, okay? But anyway, moving on. This is a much better representation of the angle, the look down, okay, of the engagement and the aspect. So we're basically looking off the left side of the aircraft now at a F-16, and this is at 6.2 nautical miles. So it's cut off. There's not much video on the internet, so I can't really blame people for not understanding how this stuff works, because a lot of it is classified and they don't let us release it, and so we just no one's scared. Everyone's scared to put anything. You're not going to put any video of something classified onto the internet, right? So people just don't put anything on because they're not sure. But you can see here, right? This is 6.2 nautical miles. I believe he's slightly zoomed in. So narrow field of view, and I believe he's slightly zoomed in. Okay, I feel that. But I'm not sure. You would be able to see it over here. It'll tell you your zoom. There's a hog knob in the Viper that you can actually zoom digitally. Okay, but you can clearly see this is an F-16, right? This is 6.2 nautical miles. Like, I can tell what it's carrying. Okay, I know there's no missile on this station. Okay, I think that's an AIM-9 actually. That's probably a heat-seeking missile. I can see it has a wing tank. Okay, so there's a tank on this other side. I can see this. It has nothing carrying on this station. Okay, that thing's empty. That's just a MOW. And then here, it looks like on this missile station, I would say that's an ACMI pod. It's like a tracking pod that we use. I know it's in infrared mode, okay, without seeing the little IR TV up here, because I can see the heat. Okay, I can see the exhaust. And you can tell there, like this is accurate. Okay, I can see, let me get a little bit more. Okay, you can see here, like, how it dissipates. Okay, it's really dark here, there's defined lines, and then it dissipates there because the heat is dissipating into the atmosphere. Okay, and you can even see here it's cooler here. If you've ever seen a fighter, you know, when it's pulling a lot of G's, and you'll notice right along the intakes here, or right along the strakes of the aircraft, is where the vapor, the water molecules actually come out of the air, and so that's cooler, right? I can even see that here. Okay. And I can see, okay, so it's very accurate, but what can I see of the background? Do you know what the background is? Can you tell? Because it's about the same, right? We're about 6.2 nautical miles away. The look down appears about, 20 or 30 degrees from what I'm telling you, but you can't make out the background at all, right? And as it goes, you'll notice, because the background is moving twice as fast as the F-16, because it's a line of sight, right? I mean, just think about it. Imagine you had a camera, you focus on something, right? I focus here, okay? You're focused, come on, focus. Okay, you can't see this, right? But as I move closer, I get closer to the focal length. Okay, now it comes into view. Okay, the targeting pod is the same thing. It's still using optics. It's just optics in the infrared spectrum. The wavelengths are a little bit longer, right? So that's why you don't see the quite level of detail, but it goes through clouds, and it can tell very long distance. Okay, so look at this. Could you tell what's in the background? I mean, to me, it looked like valleys. Look at this. Okay, like this looks like a ridge. You see how it's cooler? So the sun probably is coming from this direction and heating. He's in black hot. So the sun's coming from this direction because the jet is hot. And the jet's going to be hot because it's traveling through the air fast, creating a ton of friction. So this is probably where the sun's coming from. Okay, so I know this side's going to be hotter than this side. So this tells me it's a ridge. All right, so this is like a little mountain. Okay, this ain't a wave. Okay. All right. Now let's go to the GOFAST video. So this is at the beginning. All right. And I want to show here, there's tons of information already. Okay. You can see here that the waves, right? You can tell that's water, right? I mean, before you couldn't even tell what it was at all. Like it was a valley. I mean, I can see a valley because I see it, right? I've been looking at this stuff for hundreds and hundreds of hours. I mean, people ask me what fighter pilots do, and this is what we do, man. We get down to the physics of stuff. I mean, we shoot our weapons go Mach 4, right? If a missile is off and it's going Mach 4, if its targeting information is slightly off, man, that is 4,000 miles an hour. That's 4 times faster than a bullet. If that thing's off by like minuscule fractions, you know, it's gonna miss. And imagine at many, many miles, okay? These missiles have to be accurate. So all right, so look here. The water is in just like that. So I can tell that I'm in black hot, so the same thing. So this little spot here is a little bit harder than this spot, okay? This is cooler. You can tell this is waves. Probably not that big, okay? And by the way, if you look at the angle, okay, so I know this is 22 degrees down. I know I'm at 25,000 feet, okay? If you do the hypotenuse of that, it comes out to almost 11 miles. So this is at 12 nautical miles, zoomed in through a little targeting pod. We can count these little waves. Think about that first off. And now I want you to see what happens when the object comes into view. And the other thing is, I think he's in a ground mode, okay? So the way I think they caught this thing is they see it visually, they're directed there somehow, they see it visually, they can't pick it up on the radar. Why? Because there's no ranging. Okay, this range that comes up that Mick West says is like this, it's obviously at this range. It is not at that range, man. The jet doesn't know where this thing is. That is a guess. Okay, there's no radar tracking data on this thing. They don't fire the laser, right? We can get laser ranging if we shoot a laser at it, but they don't fire it. I bet they do, but they don't fire it. So the jet does not know how far away this thing is. Okay, so here's it. First I want to show it's not in focus, right? It has fuzzy surroundings, okay? And the waves are actually in focus, right? Okay, still not in focus. He resets, not in focus. Boom. Okay, now it's locked. So now I want you to look. Look at the waves. They're just a little bit blurrier, little out of focus, right? Meaning, but look at the white thing now. Let me see if I can get a better one. I mean, that thing is in focus. That thing is locked. To me, it looks like just a white ball, like a ping pong ball. And since we don't really know how far away it is, we don't really know how big it is yet. Okay, I can show you how we can estimate it. I show with this model I made. So in focus, and now the water is slightly out of focus. So here we go. Try it again. Look. In focus. Boom. Now it goes, this is in focus, and that's slightly out of focus. And you could say, well, because it's moving, right? That's what Mick West would say. I mean, you could say that. All right, the next thing I want you to look at is the vector that this thing goes. Okay, so watch. Here's the velocity vector. Here is the velocity vector, okay? And as we continue along, as it's moving, okay, it's not changing, right? It is not changing. But the plane that we are in, the observer, is changing position, right? We can all confirm that. The fighter is moving at 0.6 Mach. And yet, the relationship between the target and the background sure doesn't change that much. What are you looking at? Maybe that much. So what I did, guys, I thought, like, how can I explain this to you? Like, it's so obvious to me that it's kind of hard to explain. So I just had to go back to basics, right? And that's what we do, man. That's what fighter pilots do. We draw it out, okay? We pencil, paper, man. I went and bought a protractor, and I set up this model, Mick West. You can go ahead and reproduce this at home, at your leisure, and tell me your results. Normal foot-long ruler, right? And if you look, if I put it here, each square is a foot, okay? So each square is a foot. In the video, we know what the fighters are doing, okay? The disagreement is on what is the object doing. So in the video, the F-18s are going 0.61 Mach. 0.61 Mach is rule of thumb, 6 miles a minute. Okay, 6 miles a minute is 1 mile every 10 seconds, which means they go a foot every 10 seconds. Okay? So I've laid it out, and what I tried to lay out, you see the lines here are with the orientation of where the object is actually going. Okay? Let me just grab the... Okay, so, and I set up the podium here. Okay, I dropped a plumb line. So here's the origin. This is point 1. I measured a foot over. This is to point 2. And then a slight turn, okay, to point 3. So the fighter is going this way. So what I want to show you guys is the easiest way to debunk this is focal length. So the targeting pod, if Mick West bothered to ask anyone that ever flew with this thing, ever, or operated it, any weapon system officer, any test people, any pilots, okay, yes, you can sit in a lab and you can sit in your garage and hold up a bright light and try and debunk stuff, or you could just ask someone who's actually done this shit for decades. First thing, biggest way it's automatically debunked, okay, is the camera. It's a camera, okay, it's in the infrared spectrum, but it still has a focal length, right? So this is 1 foot, right? It's A4 paper, yeah, you're up. This is 1 foot, okay? I've driven a line across here, so I drove 15 lines, so that's about 89, 90 meters between each one of those lines, okay? That's a football field, right? So I've put this exactly, so 45 degrees is here, okay? So I believe that is setup point 1. And what I want you to see here, I'll zoom in, okay? You'll notice that the vector line, okay, lines up, okay? So that's the first point. You'll notice at the beginning, like I said, the water is in focus, correct? And then they lock on to the target. And the water is still sort of in focus, but slightly off. Okay, you can still tell it's water, right? But so let's look. All right, so I'm going to change the focus point of my camera. Can I see the target? No, I can't see the target. Now I can see the target. I can't see the paper. Now I can see the paper and the lines. You see? I can make out definition. Can't make out definition. And you can see the height here is 26.5 inches, okay? And the height of that is 48 inches, okay? I can't really see detail. I'm not seeing the lines, the water in the lines, okay? Now I can see it. Okay, so that is point 1. So as they move along, we go 10 seconds over to point 2. So I'm going to move the camera here, okay? Okay, so you see here, this is point 2 now. We've gone 10 seconds. I'm lined up with where the fighter was. We use the same angles. And now, what I want you to look at is the background angles as well. So the angles, you'll notice the angle between this and the angle between the lines will change, okay? But the angles between the lines, as I'm moving everything this way, right? I'm moving it with the line of motion of the object. Now as we move this with the lines, right, moving with the lines, you see that the lines are now off. So the line of motion between the object and the background is relative to how close it is, right? Here it's going to be the same. Here you're going to get much more background image, right? Because this point is 10 miles, right? And this point is only like 4 miles. Does that make sense? So the background is going to move faster. So you can't focus on everything at once. It's just not how optics work. So this is point 2, okay? Now I'm going to move it forward to point 3. And as I move it, just watch the object, okay? I just turned it here. I'm going to put it in focus relative to its background, okay? So I'm going to move it, try and move it slowly. Okay, I'm just moving it to the right, right? Look at it turn. Do you see how it's turning in relation to, here, I'll move it back. Look, see how it appears to rotate? It's basically rotating, right? It's rotating. I'm just moving it left and right, right? To the left, to the right, but it is rotating, and that's just due to something, it's in the background. That's how optics work. We can't focus onto everything at once. So let me line it up with my pre-marked measured stuff before. Okay, so we go, there is the object. This would be on the surface of the water, okay? Traveling what I believe is in a vector this way. And now, how close did I get? I mean, pretty close. Okay, can I see the lines in the water? No, man, you can't see anything. Okay, now there it's clear, right? Here, can't see anything. There it's clear. And then look at the orientation, okay? So if you move above, look, if I move this tripod, I'm gonna pick it up. Okay, look above, okay? Look, it's lined up with the lines. You get it? It's lined up. But here, it's not. Oh, sorry. All right? But here it is off. You can clearly see it's off from the fighter, right? And the lines behind it. It's slightly off, maybe like 15 degrees, but I didn't move it much. I mean, I've literally walked 2 feet to the right. So I don't think it's here, okay? But I also don't think it's that close to the water. I don't think it's right above the water, okay? So here's what I actually think, okay? So it's somewhere in between the water and, I don't know, a few thousand feet. Okay, so I would have taped a ping pong ball to here. But now let's go back, and I measured it out already. So lining up, that should be relatively in line as the third point. Okay, and this is the maximum I think it is. And what's even cooler now is we can actually estimate the speed of this thing, which is super cool because we know where the fighter is, right? We know where the fighter is, and we know it's looking along this axis. Okay, I changed the camera to get a better view. So we know it's looking along this axis. We just don't know how far it is from the camera. We don't know how far it is from the fighter. But we know it's somewhere in between here, right? I know it's no higher than a mile, and I know it's not skipping below the water. So if we measure, which I did, the distance that these objects would travel if they were at that distance, this is going Mach 1.0. So if you measure this, right, remember each is a mile. So we have the time. So we know it goes this far in 10 seconds. So that is Mach 1.0. If we measure this, okay, at a mile above the surface, now we get to a Mach of half that. So half Mach 0.5, which is the speed the fighters are going, 0.6, which is 6 miles a minute. But it's somewhere in between that range, okay? I think it's much closer to the surface of the water, around 1,000 feet above the surface. And so that would put it closer to supersonic, closer 0.85, 0.9 Mach. The closer it is to the water, if we know the altitude, then the faster it's going. So it's still going 0.85, 0.88 Mach, which is 550 miles an hour. Very fast, low altitude, pushing through that heavy air. This thing is going fast, but not supersonic. So I'm not out there to like put someone else under the bus. I know another fellow YouTuber under the bus or anything. I'm not out there to attack somebody, but it's just wrong, and he needs to be told. At least don't go on like national TV and say confidently like, this is definitely not a vehicle, it's a trash bag. I mean, before you do that, dude, please ask someone, anyone who's doing this, who's used one of these things. That's it for this week, guys. Sorry for all the aggression, but it is frustrating. Guys, if you like my content, please like and subscribe. I mean, the reason Mick West is on TV is because he has thousands and thousands of subscribers. So he gets thousands and thousands of views, and so he must be this great scientific debunker. So they put him on TV, and then people don't cross-check it, and